Alexander Kornbrust on Orasploit. Thank you.
Okay. It seems there was a small communication problem because today I'm not talking about Orasploit because at the moment we are a little bit behind schedule, but I have another interesting topic about finding sensitive information in databases and how to get sensitive information without leaving traces in the database. So for example, stealing credit card information without triggering auditing. And I hope you enjoy this as well. And questions are always welcome. A little bit marketing blah blah. So we are only specialized in Oracle security. And in the last 4 years we found more than 350 Oracle vulnerabilities. But in the meantime Oracle is more or less happy with us. And we are traveling all over the world and giving trainings and presentations. So first I talk a little bit about passwords, because in most cases you think, oh, it's lame, everybody knows where an Oracle password are stored. But in the real world, if you test databases, and we test tons of databases every year, you have not only passwords in the Oracle password tables itself, you have normally custom tables. And on average you find 6, 8, 10 tables containing passwords in the database. And these passwords can often be used to get additional access in further systems. For example, do you know what the meaning of this word is? Or this? No one speaking Afrikaans? All these words means password, but in different languages. Because even if English rules the world, a lot of people prefer their local language. So for example, people in Germany or Austria, Switzerland, they are often taking the column name Kennwort. Yeah, it's unusual. And the first time I saw this in France, because especially people in France don't like the English language. So in France, or this French-speaking part of Switzerland, you find a column called MDP. And this column MDP contains often passwords. And every custom application, they are normal developers without a deep security knowledge. So what do you think are, here are some typical words, for example, mot de passe, lösen, Sandi is Indonesian, and so on. And as a proof of concept, as a reality check, you can use Google. So if you search for create table and then MDP, you find 170 code lines or 167 hits containing create table, and here you see MDP 30 characters long. And it's also possible for Geslo. It's not so popular if it's a smaller language, but this is quite useful. So I did my collection. I asked some of my friends all over the world, Stefano, Philippe, and I also used online dictionary. So every language, if I saw English to Indonesian, then I checked for password. One of the problems are non-Latin characters. For example, what happens with Russian? So the first step, I asked people in Russia, are you using Russian characters for column names? They told me, no, we don't use Russian characters. We always use the English word. But that's not true, because I translated the Cyrillic characters into the Latin characters. And then, if you know Cyrillic, you see here the Russian word for password is parola. So the next step was looking up in Google, and you find really tables containing the column parola. And the problem, these tables are used by custom developers. So custom developers do not have a big security awareness, so they are using normally clear text. So in most cases, if you find custom password tables, you find clear text. And from our experience, this is in most cases clear text. Sometimes you have base 64, you have MD5 sometimes, or Caesar chiffre. And now, because large databases often contain several thousand of tables, we automatically try to classify the passwords. And at the end, you will also get a script. You can download also the script next week from our website, which automatically tries to find passwords and classify the password itself. For example, if you have such a password column, you can analyze the content of this column. If it contains only hex code, then you know it's probably a hash value, and then depending from the size, you know it's MD5, and MD5 is quite common in the Oracle world. If there are duplicates in a column, then you know salt is not used. With statistic analysis, you can count how many E's are available in all the passwords, or base 64. But from our experience, the most common is clear text. And the concept is quite simple for such a script. You create a cursor, a statement over all tables. So we have DBA tab columns, and then we check if the table name, if the column name contains, for example, PWD, or mot de passe, or Haslo, and so on, and it continues. Sometimes you find also proxy password. These strings are also quite common. And we have a list of 50 different typical column names. And then you run this script once, and then you get output with the different columns, how many passwords are available, and so on. And then it's pure PL/SQL. So in the next step, we generate dynamic SQL statement, which is executed afterwards. And here, for example, we are checking if the length of the password is 32, then we know it's normally MD2, MD4, MD5. But in the Oracle world, it's normally MD5, because Oracle offers MD5 library in the database, but not MD2 or MD5. And most people use the already existing stuff. And we check, for example, if salt is in use or not. So the output, the only thing you must do is call this add and then the password script, and then you get a list of all the tables, username, table name, column name, and possible text. And for doing a security audit of a large database, this is quite useful. Or we found that it's quite useful. And if you have enhancements, just do not hesitate to contact us. There are also some possible enhancements. In Oracle, it's possible to do HTTP calls from the database. And for this, Oracle has a function called UTL HTTP request. And there are also some websites in the internet, for example, md5.rednoise.com, and these websites contain a rainbow table with MD5 hashes. And in this case, we are using the UTL HTTP request to crack all the passwords in this table with one SQL statement. So Oracle is doing for every password, which is stored in web password raw, every password is sent to this website, and the result, if the password is found, is returned. And this is part of Oracle Apex, which is also installed by default in Oracle 11g. And you see that just with a few SQL statements, you can get passwords. And the idea why we concentrated on this, we are using this for password crackers. Because if someone is using a clear text password, super duper 2007, then the possibility that he's using this password in other environments is quite high. And we think it's much more promising to use passwords from such tables instead of doing brute force attacks. because normal users do not use random passwords. Normal users take passwords from football clubs, car brands, and so on. This was everything to credit card, to passwords. The next problem where you can find sensitive information are credit card numbers. Before we start with the credit card numbers, do we have frequent flyer here? Is someone member of Star Alliance? Yeah? I will also show that this Star Alliance has a security problem. We will see this soon. So I guess everybody here in the room knows that credit card numbers are sensitive information. So that's lame, everybody knows this. There's also some regulations like PCI DSS, which requires encryption, but even then a lot of customers are not encrypting the data. And normally it's not allowed to start credit card data unencrypted in the database. And during this presentation I will show that even if you store the credit card data encrypted in your database, you can get the unencrypted data independent from the encryption algorithm. And it's clear that people are not only using the column name credit card to store credit cards, they are also using their local variant. So using an online dictionary, you can also convert this. A typical credit card table looks something like this: credit card, CVV, and expired. If you search this in Google, you also see people are storing this quite often in the database. Oracle has also a white paper on their internet site showing how to encrypt credit card data. But Oracle recommends to use TDE. TDE is transparent data encryption. This is an add-on feature which allows you to encrypt credit card data with one single command. So you just say encrypt table, and then the entire table is encrypted. And according to the Oracle website, this is sufficient to be compliant with the PCI DSS standard. The problem is the T in this abbreviation TDE. It's transparent. This means if the database is up and running, the encryption is not present. So everyone which comes from the database or the application layer, which is one layer level higher, can access the credit card data. So in my opinion, it's more or less useless. For an attacker, it's even easier because Oracle has a nice view called DBR encrypted columns. So you see what data is useful in what data is important in your database. So just look what is encrypted, because if it's encrypted, it's more or less important. And then you can directly select stuff from credit card, and then you have all the information you need. The problem is, this is a nice feature because a lot of auditors are doing paper audits. So if you say our credit card data are encrypted with AES 256, everybody believes, okay, that's true, it's super secure, military grade. But in the reality, everybody can read the data. So in my opinion, this is unsecure and useless. If you use Oracle to store credit card information, TDE can help you a little bit to encrypt the data if someone steals your data files. But if the database is up and running, this does not help. It's like clear text, or it's clear text. The problem, if you don't know how a column is called, how can you find credit card information? And the easiest way are regular expressions. Because in the internet there are large libraries with useful credit card information. And since Oracle 10G, it's possible to use regular expression in select statements. So what we can do is we analyze every table and the data and check if it's a valid credit card table or not. And in this case, we can, it doesn't matter how the column name is, we just analyze the data and can find out, okay, that's a credit card number. Or in the United States, we can check if this is a social security number. This is useful because in the real world, developers often use temp tables. So they have a temporary table, and for some report or something like this, they copy parts of the main table into a temporary table. And these temporary tables are often not deleted afterwards. And here on this website, regexplib, you find a large list of regular expressions, and these can directly be used in Oracle 10G. Another problem of credit cards is the dual use, because credit cards are used on one hand to pay something. But in many cases, if you are a frequent flyer, these credit card numbers are also your your frequent flyer number. For example, I'm not sure if someone of you has a Miles & More credit card, and if you have the special level from Senator or higher, you get this credit card for free. And the problem, your frequent flyer, Miles & More, is the biggest frequent flyer program in the world, what I saw. And most of the higher levels, they have a free credit card from Lufthansa or Austrian Airlines. And for convenience reason,
two numbers.
No.
One number for the step and one number to pay, and you don't mix up the numbers.
You can use this as a frequent flyer number. Normally you have three numbers. You have the old, starting with 99.
But you're stupid because you're putting this number into unencrypted reservations.
But so many people are doing this because normally you have only this card and only one number is on this card. And that's your credit card information. And a lot of people are using this in games to attend a game 2 times because they use the old and the new frequent flyer number. And if you go to the typical forums for frequent flyer, people recommend to do this.
And expiry is always February 2016.
Right, that's the problem. So you must just set up a website and saying, okay, please specify your frequent flyer number. And then the expiry date is predictable because it's always February 2008 or 2009. The CVV code is normally not part of it, but it can be guessed quite easily. Just go to a website and try to buy something with the CVV code 001. And then if you get the error message, you know it's not 001. Then you try the next.
And after 10 tries the card is blocked.
Not always. If it's blocked, then it's a denial of service. But on many web shops, it's not blocked forever. So they do not have this check that everything is blocked after 10 seconds. So for example here, there's also a game. Here please specify your card number for Miles & More. Or if you do online check-in, you must specify your frequent flyer number. But this is the credit card number. And I expect that the people will store all this information in a table unencrypted. That's why if you look in a database, you should always check for frequent flyer numbers. Also, there are tons of winning games where you can win money, where you can find this information. And in my opinion, this is a security problem of the Miles & More card. I would recommend to offer to print an additional card, an additional number on this card to avoid this kind of problems. The question is, credit card numbers means money. Because if you have a lot of credit card numbers, you can sell them, and it's a cheap way to get money if you have DBA privileges. But especially credit card databases are using a lot of, or should use a lot of security measurements. For example, auditing and this kind of information. And now I show a way how to get information without leaving traces. So no objects, no audit entries, and so on. Even if you do not store the password, the credit card numbers in the database, you can get this information. And the reason for this is a special view called $SQL. In Oracle, there's a view, $SQL, and this view contains the last few hundred, few thousand statements. So whatever you submit to the database, insert, update, delete, function calls, everything is accessible via this view. So whenever you deal with credit card information or other sensitive kind of information, it's accessible here. And for some reason, I don't know why, it's not possible to monitor the access of this view. So you can normally enable auditing for most of the objects in Oracle, but for this object it's not possible.
Because it's recursive. Because the audit itself generates more statements that go also into the view.
Right. But even then, Oracle should be able, not every statement is visible in the $SQL, so they should be able to deal with this. Right. And it's also and this means everyone with DBA privileges can select data from this table, from this view. Here I have a small example, credit card table, and here we insert our data unencrypted. And with one select statement, we get all our insert statements. And this is also true for all kinds of sensitive information. And the DBA can run a script every 2 or 3 minutes, and then over the day he can retrieve hundreds or thousands, depending on the traffic, of credit card information. Now you could say, okay, we do not store the credit card information unencrypted on the database. Or we do not store the credit card information. But in many cases you do authorization against the issuer of the credit card. For example, if you have a function authorize where you pass the credit card number, CVV, and expire date and the name, this function call is also accessible via the $SQL. So even if no encrypted data is, even if the credit card data is not in the database itself, it's accessible via the memory. Some people could say, okay, nobody is doing this. Most people in the Oracle world are using bind variables, but from my experience, not everybody is using bind variables. And even if you use bind variables, which is much more performant, there's another view, and we can also search credit card data. If you don't know the function call, we just search with this regular expression. So whenever a credit card pops up, we get this information. If someone is using bind variables, for this case, Oracle has a function called view $SQL bind capture. And in this special view, you get all the values of the bind variables. So a small loop and you can collect everything. The problem, there's no workaround, because if you use direct calls or function or bind variables, it always appears in the $SQL. The only way to get rid of the $SQL is to flash the SGA from the database. But if you do this, you will have a big impact on the performance because you lose all your optimization. And I talked with Oracle about this problem, and they told me, yada yada yada, you must be careful who's becoming DBA and so on. In my opinion, it should be possible to have a switch which blocks the visibility. Because you don't, it's not only the database, you see also the passwords. I did a short check of the packages and functions and procedures of the database. And there are 160 functions and procedures from Oracle itself which are accepting passwords as a parameter. For example, there's one package called OWA, and this package has a function called setPassword. Even if this password is not stored somewhere, it's visible again in the $SQL. So if you search for OWA set_password, you get here this function call. What I did, I generated SQL statements, and in the meantime I have 500 different SQL statements revealing clear text passwords. So for every security audit, we check first if the database memory contains passwords, and then we are using these passwords to crack the Oracle database passwords. Because quite often passwords are reused. And also here Oracle told me all these passwords are used internally, so it's not a security problem. But Oracle is aware that for some commands it's a security problem. If you, for example, change a password, alter user sys identified by password, this password is removed, but Oracle does not remove the password from such function calls. And I would expect something like a special flag in a statement, and in this case the statements are not visible here. But Oracle is not interested in this. Also, if you do auditing and you monitor all the SQL statements, these SQL statements also contains often passwords. So if you run this set password and you audit the usage of this command, this password is written in the audit table, and for performance optimization also in the WHR $SQL text. That's why in most cases you find passwords in real-world databases. Especially security experts often test on a vanilla plain database, so just next, next, next. But if you go to a real company with real data, you find passwords, because they have often copied schemas and so on. I'm faster than expected, but it's, I think, not a problem. Information is often stored in the database in local languages, non-English. And if you are working in a company, it's a good source for a custom company dictionary file. But if you do this, you must be really careful that this dictionary file does not leak out. And for legal reasons, you should always contact your lawyer or your workers' council, because using customer passwords, if they are stored in clear text, can be dangerous. And in Germany, for example, it's not allowed officially. And in the database, you can find credit card information and all kind of sensitive information, often in the memory using these views $SQL. And data is often used in two ways. And one of the examples was this credit card information. Even if you use bind variables, this does not protect your database from the leakage of information via this $SQL. And the only solution I found so far to monitor that, to see that someone is accessing this table to access information are some external security solutions like Centrigo Hedgehog. And if you have questions, you can ask Slavik, he's here. Okay, that was more or less passwords and credit card information. Any questions? Yeah.
I noticed you had a lot of table names like user passwords, and you were checking for. Is there a reason why you don't check if the word pass just occurs in a table name or in a column name?
From my experience, if I just use pass, you have sometimes too much false positives. You can also work with. It depends a little bit from the company. Where was it? You can here also work with wildcards, percentage, pass percentage, but we got a lot of false positives using this.
Okay.
But that's just our experience. It depends a little bit how your developers are working. So if you just in your company, then it's normally easier because you know how people, what naming convention are used and so on.
Okay. Yeah. I would think with password you wouldn't get that many false positives with the whole word password.
Right.
Okay.
But even then, for example, I guess you are from Netherlands?
Yes.
So you have this wachtwoord.
Yeah.
Have you saw this already in databases?
Mostly in Dutch databases they use password, but sometimes we see wachtwoord, yes.
Okay.
Okay, thank you.
Other questions?
Regarding the time variable, is there a way to obfuscate that? So, is there any workaround for this, or regarding the band variables, is there a way to obfuscate there, or a workaround to get rid of this, because this is a pretty big issue for like
Not that I'm aware of. So normally after 10-15 minutes, these values last in first out, they are removed from the cache and then they are gone, but for 10-15 minutes it's visible, this information. And you can also flush the memory, but nobody is doing this because then all the optimization statistics is gone.
What is your recommendation how to store credit card numbers in databases encrypted?
Encrypted, but I would recommend to do the encryption not in the database itself, on the application layer, okay. And then save the encrypted string in the database.
All right.
And also avoid the clear text passwords, something like these function calls. So if this function call is done by the application server, then it's not visible here. But it really depends from the architecture of your application, if this is possible or not. And it's not only for credit card information, also if you have company secrets, depending on your business, you should always keep in mind that this is visible in the database memory. And also in trace files. Sometimes if you use trace files, dump files, this information is also available there. So for example, depending on the Oracle event you're using, this is also written to the text file on the operating system level.
But if you don't encrypt it via a database, then it's quite complicated if multiple applications access the encrypted data. Where and how to store keys?
Encryption is a complicated topic and there's no perfect solution. So at least you should be aware that this is a potential leak. And it's not a violation of the PCI DSS standard, but data can still leak out. So in the database it's the easiest way, but it's not the safest. Okay. Should we switch directly to Lucas?
Well, I need a couple of minutes to set up my equipment, so.
Okay.
Right, so no more questions. In that case, I would finish the session. Thank you very much, Alexander.